Okay, so picture this. You're prepping for that big senior software engineer interview, right? And the technical deep dive part. It's like walking into a thick fog, hoping you kind of know the lay of the land.
Yeah, I get that.
And we're here to help clear things up a bit.
Yeah,
Today we're going to shed some light on the really foundational Java concepts.
right.
Think of it like sharpening the tools.
Yeah.
You already have those essential building blocks that might seem basic, but they're really crucial when you're building complex systems, and definitely when you're trying to confidently talk about technical stuff in an interview setting.
Exactly. And even if you've been working with Java for a while, revisiting these core concepts can be incredibly helpful, especially when you need to articulate them clearly in like a high pressure situation like an interview.
Absolutely.
It's about having that solid foundation so you can really build upon it.
Yeah, and where does almost everyone begin their journey with a new programming language? It's the legendary Hello World program. Right?
Yeah, the classic.
It's like the first handshake with a new technology.
Definitely.
Now, it might seem super simple, but even that tiny bit of code actually tells us a lot about how Java is structured underneath.
You know what's fascinating is how this seemingly basic program, it showcases some of Java's core design principles right from the get-go. It's not just about displaying some text on the screen. It's a glimpse into the object-oriented world of Java and how everything is organized.
Yeah. Okay, so let's break it down. The typical Hello World program in Java looks something like this. You have package, cheats801.sx01, public class, hello world, public static void, main string args, System.out.println no world, hello world. Now, for someone coming from a different programming background, or even if you're familiar with Java but haven't looked at this basic structure in a while, what are the key takeaways here?
So the first thing that stands out is the structure itself. Java is all about objects. Think of them as self-contained units that hold both data and the actions you can perform on that data. These units are called objects, and they're created from blueprints called classes. In our Hello World example, the Hello World, that's our blueprint. That's the class. Okay. And the structure where everything lives inside a class might feel a bit verbose at first glance, but trust me, it enforces a discipline that's super valuable when you're dealing with large projects, especially when multiple developers are collaborating. It prevents the chaos of having global variables all over the place and code that's not well organized.
So it's like a way to keep things tidy and manageable from the very beginning.
Precisely.
Okay, so we have our Hello World blueprint. And inside we have this line, public static void, main string args. This is the part that actually kicks things off, right?
Exactly.
But what's the deal with all those keywords? It almost feels like Java is making us be super specific up front.
You got it. The main method is like the designated starting point for any Java application. When you run your program, this is where the execution begins. Let's break down those keywords a bit.
Okay.
So, public, that controls visibility. It means this method can be accessed from anywhere outside the Hello World class. Then we have static, which is super important here.
Yeah.
It signifies that the main method belongs to the Hello World class itself, rather than to a specific instance of that class.
Okay.
At the very beginning of a program, no Hello World objects have been created, yet static allows this main method to be called directly on the class.
So static means it's associated with the class itself, not a specific object.
Exactly.
What about void then?
Void, it simply means that this method doesn't return any value after it's done executing. It does something like printing text in this case, but it doesn't give you back a result, like a function that calculates a sum might.
Right.
And then there's string args. We can touch upon that briefly. It's an array of strings that allows you to pass information into your program when you run it from the command line.
Okay.
It's a way to make your programs more flexible, but we won't dive into the details right now.
So we've got public static void main. That's our standard entry point. Now we also see public being used for the Hello World class itself. Is that the same idea of visibility being accessible from other parts of the program?
You got it. Making the class public means it's accessible and can be used by other classes within your project and potentially even by code in other projects. It's the most common setting for classes that are designed to be used and interacted with.
Okay, so it's like opening the door for other parts of the code to say, hey, I want to use this.
Precisely.
Right at the top, we see this line package, h01.sec01. What are packages all about? They sound like a way to organize things like folders on a computer.
Absolutely. That's a great analogy. Think of it like organizing files in folders. Just as you wouldn't dump all your documents into one giant directory, packages help us avoid name clashes and make it much easier for teams to find and understand related parts of a large code base. So packages, they're essentially namespaces that help you organize your Java classes. They serve two main purposes. First, they group related classes together, making your code base more manageable as your project grows.
Huh.
And second, they help prevent naming collisions. If you have two different classes with the same name but they're in different packages, Java can tell them apart.
Got it. So it's like having a well-organized filing system for your code.
Exactly.
Makes a lot of sense, especially when you start working on bigger projects where you might have hundreds or even thousands of classes.
Right.
We also see these lines starting with 2 forward slashes. Those are comments, right? Just for us humans to read.
Exactly. Single line comments, those are completely ignored by the Java compiler. They're there for developers to add explanations, notes, reminders directly within the code.
Okay.
For longer explanations, you can use multi-line comments. Those are enclosed between. There's another type documentation comments that use and which are used by tools to automatically generate documentation for your code. Super helpful for larger collaborative projects.
Okay, so we've looked at the structural elements. Now let's get to the line that it actually does the work. System.out.println. Hello world. Let's break this down piece by piece. What is System.out?
Well, think of System.out as the standard way for your Java program to show its results, like when you see output in your terminal.
Right.
Technically, it's a predefined object that represents what we call the standard output stream. It's the default destination for anything you want to print out as text.
Okay, and then we have this, .println, hello world. This dot notation seems important.
It is. The dot notation is how you tell an object in Java to do something, or in more technical terms, it's how you call a method on an object.
Okay.
So here, println is a method that belongs to the printstream class, and system.out is a specific instance of that class. Println, it stands for print line, and it takes an argument, which in this case is the string of characters, hello world, and it prints that string to the standard output followed by a new line. So that dot, it connects the object system.out with the specific action we want it to perform, println.
So it's like telling the standard output object, hey, print this message.
Exactly.
You mentioned earlier that Java is designed for larger programs and that everything lives within a class. And you pointed out that this can be a bit more verbose compared to some scripting languages.
Yeah.
Could you elaborate on why this consistent structure is actually a good thing, especially when we think about maintainability and collaboration, which are huge in senior roles?
You're absolutely right. It's about understanding the trade-offs.
Yeah.
While the initial structure might seem like you're typing more for simple tasks, this uniform approach, where all code lives inside classes, brings significant advantages as your systems become more complex. It provides a clear organizational framework, making it easier to understand where things are defined and how different parts of the system interact.
Right.
In contrast, some languages allow code outside of classes, which can lead to a less structured and harder to manage code base over time, especially when multiple developers are involved.
Right.
Java's insistence on this class-based structure promotes better code organization, easier collaboration, and improved long-term maintainability. And those are all crucial aspects of being a senior software engineer.
Makes sense. So it's about the bigger picture, not just about writing a few lines of code.
Exactly.
Okay, so we have our code.
Yeah.
How do we actually make it run? Well, you mentioned we need the Java Development Kit or JDK. What exactly is that? And do we absolutely have to use an integrated development environment or IDE like Eclipse?
So the JDK is the essential toolkit for developing Java applications. It includes the compiler, which is called the Java Virtual Machine, or JVM, and a whole bunch of other tools and libraries that are needed to build and run Java software. An IDE like Eclipse, IntelliJ, IDEA, or VS Code, these are optional but highly recommended, especially when you're dealing with larger projects. They provide a user-friendly interface with features like code completion debugging tools and integrated build systems, which can really boost your development efficiency. But for our simple Hello World program, you can definitely compile and run it using just the JDK from the command line or terminal.
So let's say we're going the command line route. What are the steps involved? I seem to recall there being two distinct commands.
You're right. Assuming you have the JDK installed and your hello-world.java file is in the cho1senate01 directory, the first command you would use is javac chedo1 sega1 hello-world.java. This invokes the Java compiler javac, which takes your human-readable Java source code and translates it into what we call bytecode, which is platform independent.
Okay.
This bytecode is then saved in .class files. In this case, you'll have a hello-world.class file in your che01 serina1 directory.
And that bytecode, that's what enables Java's write once, run anywhere capability, right?
Exactly. The .class files with the bytecode can then be executed by the Java Virtual Machine, or JVM, on any operating system that has a compatible JVM installed. The JVM acts as an intermediary abstracting away the underlying operating system. And this is where the second command comes in Java cheats01.sex01. Hello world. Notice here we're using dots to separate the package segments, and we omit the .class extension.
Right.
This command launches the JVM and tells it to execute the main method of the hello world class that's within the cheats.hr1.sex01 package. And if everything is set up correctly, you should see hello world printed out in your terminal.
And that's the beauty of Java being able to write the code once and run it on different systems without having to make major changes.
Exactly. That write once, run anywhere aspect is one of Java's biggest strengths.
You also mentioned that sometimes for a single source file, we can skip the explicit compilation step. How does that magic happen behind the scenes?
Yeah, that's a newer feature that was added to the Java launcher. For simple programs contained in a single .java file, you can directly use the Java command followed by the source file name. So for instance, Java chase01 s01 hello-world.java. The JDK will then automatically detect that it's a source file, compile it in memory, and immediately run the resulting bytecode all in one step without creating a separate .class file on disk.
So it's like a shortcut for quick tests and simpler examples.
Exactly. It's super handy for prototyping or trying out small code snippets.
What about making a Java program executable on a Unix-like system, like Linux or Mac OS? You briefly mentioned that as well.
Right, so for that, you typically rename your Java file, removing the .java extension. So for example, you might rename hello-world.java to just hello.
Right.
Then you would use the command chmod plus x hello to make that file executable.
Okay.
And finally, you'd add a special line at the very beginning of the file called a shebang line, which tells the system which interpreter to use to run this script.
Okay.
For a Java program, this line would look something like #.paththojdjake in Java source 17, where you replace paththojdjake with the actual path to your JDK's Java executable.
Right.
After doing this, you can usually run your program directly from the terminal by typing hello.
So that's a neat way to make simple Java programs feel more like native scripts on those systems.
Exactly.
And you also touched on running programs within an IDE. How does that simplify things?
So IDEs are designed to hide a lot of the command line complexity. Typically, you create a project within the IDE, you add your Java source files to it, and then you just click a run button or use a keyboard shortcut. The IDE handles all the underlying compilation and execution steps for you and often provides a dedicated console window to show you the output.
Right.
It also manages the class path, which tells Java where to find your classes and other project settings, which makes it much easier to work with larger, more complex applications that might involve multiple files and external libraries.
Okay. So we've seen how to write and run a basic Java program. Now let's go back to that line. System.out.println. Hello world. We talked about system.out being an object and println being a method.
Yeah.
You called println an instance method. What does that mean exactly?
An instance method is a method that operates on a specific object or instance of a class. In our example, println is a method defined within the printstream class, and system.out is a specific instance of printstream that's linked to the standard output.
Okay.
When you call system.out.println, you're essentially telling that specific printstream object, hey, do the action of printing this text.
So each object has its own set of actions it can perform.
Right.
Could you give us another example of an instance method in action?
Sure. Let's take a piece of text like hello world. In Java, this is an instance of the string class.
Okay.
The string class has a built-in method called length, which tells you how many characters are in that string. So if you write hello world.length, it will return the number 13.
Okay.
Notice that length is also an instance method. It operates on the particular string object you call it on, and it gives you back a result the length of that specific string. This is different from println, which performs an action printing but doesn't return a value. It's void.
Ah, so some methods give you back information. How would we actually use that returned information in our code?
Well, you can use the result of a method call in various ways. For instance, you could directly print it to the console like this: system.out.println hello world.length. When this line of code runs, Java will first calculate the length of the string hello world, which is 13, and then it'll pass that resulting value 13 as an argument to the println method, which will print 13 to the standard output.
So we're basically nesting actions. We're getting a result from one method and using it as input for another.
Precisely.
You also mentioned that often we need to create our own objects using this new operator. The system.out object and the string hello world seem to be available right away. Can you show us how we would create our own objects?
Absolutely. Let's look at the random class, which is used for generating random numbers. To create a new random object, you use the keyword new, followed by the name of the class, and parentheses, new random. This is what's known as calling the constructor of the random class. The constructor is a special method that initializes a new object of that class. In this case, the random constructor, without any arguments, creates a new random number generator with a default starting point.
Okay, so new random gives us a brand new random number generator. How do we actually use it? How do we get it to give us a random number?
Once you have a random object, you tell it to do things by calling its methods. For instance, the nextInt method is an instance method of the random class that when you call it on a random object, it gives you the next random integer in the sequence. So the expression newRandom.nextInt, this would first create a new random object and then instantly call its nextInt method to get a random integer.
That seems a bit temporary, though. If I wanted to get multiple random numbers, would I have to create a new random object every time? That doesn't sound very efficient.
You're absolutely right. If you need to do multiple things with the same object, it's much better to store a reference to that object in a variable. You declare a variable of the appropriate type, in this case random, and then you use the assignment operator to assign the newly created random object to that variable random generator as new random.
Okay.
Now you can call methods on that generator variable as many times as you need. System.out.println generator.nextInt. System.out.println generator.nextInt. This way you're using the same random number generator to obtain a sequence of random numbers.
That makes more sense. It's like giving the object a name so we can easily refer to it.
Precisely.
Now, when you introduce the random class you mentioned, it's in the java.util package, and that we might need an import statement to use it. But in our initial hello world example, we didn't have any import statements. Why is that?
That's a sharp observation, and it highlights something important about how Java is organized. Certain core Java classes, specifically those in the java.lang package, which includes fundamental classes like system and string, these are automatically imported by the Java compiler. You can use them directly without needing an explicit import statement. However, for classes in other packages like java.util, random, you would typically need to include an import java.util.random statement at the beginning of your Java file right after the package declaration.
Okay.
This import statement tells the compiler where to find that random class. We'll discuss packages and the import statement in more detail later, but it's good to understand this distinction.
So it's like some classes are considered so essential that they're always available without needing to explicitly ask for them.
Exactly.
Okay, we've covered the basic structure of a Java program, how to compile and run it, and the concept of calling methods on objects. Now, you mentioned a tool called JShell. It sounded like a more interactive way to play around with Java code. Can you tell us more about it and why it might be particularly helpful for someone getting ready for technical interviews where you might need to demonstrate your understanding of certain concepts quickly?
JShell is a fantastic tool, especially when you're learning Java, brushing up on fundamentals, or even if you just want to quickly test some Java code without having to write a full program, compile it and run it. It provides what we call a read evaluate print loop, or REPL. You type in a Java expression or statement. JShell immediately evaluates, it prints the result if there is one, and then prompts you for the next input.
Right.
This interactive environment allows you to instantly test things and see how Java code behaves without the overhead of full compilation, which can be a game changer for understanding new concepts or debugging small pieces of code.
So it's like having a live Java scratch pad right in your terminal.
Exactly.
How do we get started with JShell?
To start JShell, just open your terminal or command prompt and type JShell and press enter. You'll see a welcome message and a JShell prompt. Now you can start typing Java code directly. For example, if you type hello world.length and press enter, JShell will immediately calculate that and print the result, something like $1 equals 13, followed by a new JShell prompt. Notice that you don't need to wrap it in System.out.println. JShell automatically shows you the value of any expression you type.
So it's really streamlined for testing small pieces of code and getting instant feedback?
Exactly.
You mentioned that $1, that's JShell's way of referring back to the result of the previous command. Can we use those $1, $2, etc. in later calculations?
Absolutely. For example, if after getting $1 equals 13, you type $1 plus 3, and press enter, JShell will use the value of $1, which is 13, perform the calculation 3 times 13 plus 3 equals 42, and then show you something like $2 equals 42.
So you can build on previous results and quickly explore sequences of operations.
Right.
That's neat, especially for trying out different string manipulations without writing a whole program.
Exactly.
What about variables? Can we declare and reuse variables within JShell?
Yes, you can. You declare and use variables in JShell just like you would in a regular Java program by specifying the type and the name of the variable. For example, you can type in answer equals 42 and press enter. JShell will acknowledge this with something like answer equals 42. Now you can use that answer variable in any expressions you type after that.
You also mentioned a shortcut for JShell to figure out the type of a variable automatically. That sounds really helpful, especially when you're just experimenting.
Yes, JShell has some great shortcuts. If you type an expression, let's say new random, instead of hitting enter right away, you can press Shift plus Tab, followed by the V key for variable.
Okay.
JShell will often infer the type of the expression and suggest a variable declaration like random new random, putting the cursor before the equals sign so you can type in a name for that variable. For instance, random generator, new random. This can save you a lot of typing, especially with more complex object creations.
That's a time saver. What about exploring what an object can do? For example, if I have this generator object of type random, is there a way to see what methods it has without looking up the documentation every time?
Absolutely. JShell has excellent tab completion that's really useful for discovery. If you have a variable, say, generator of type random, you just type generator.
Right.
The variable name followed by a dot, and then press tab. JShell will show you a list of all the methods you can call on that generator object. You can even start typing a few letters of a method name and press tab again, and JShell will try to complete it if it's unique or narrow down the list of suggestions. For example, typing generator.nn followed by tab might complete to generator.next, and then typing generator.nextd and tab could lead you to next double. And pressing tab one more time might even show you the different variations of the next double method and give you the option to view its documentation right there in JShell.
That's super useful for figuring out what different objects can do and how to interact with them.
Definitely.
You mentioned that we can go back to previous commands we've typed in JShell.
Yes, you can use the up arrow key on your keyboard to cycle through the history of commands you've entered in the current JShell session.
Yeah.
Once you find the command you want, you just press enter to execute again.
Right.
Or you can use the left and right arrow keys to move around within the line and make any changes before pressing.
Right.
For example, you could go back to a previous call to generator.nextDouble and easily change double to int to call nextint instead without retyping the whole line.
That's convenient.
Yeah.
You also said that JShell automatically imports a bunch of common packages when it starts up. That explains why we could use random in JShell without having to type import java.util.random. Which packages are included by default?
So by default, JShell imports a set of very common Java packages, including java.io for input and output operations, java.math for arbitrary precision arithmetic, java.net for networking, java.io.file for file system operations, java.util, which has collections, random number generation, and more, java.util.concurrent for concurrent programming, java.util.function for functional interfaces, java.util.prefs for user preferences, java.util.regex for regular expressions, and java.util.stream for working with streams of data. This covers a wide range of common functionalities, which is why you can often use classes like random directly without an explicit import in JShell.
But what if we want to use a class from a package that's not imported by default, like the duration class from the java.time package for working with time intervals? How do we do that in JShell?
You have a couple options. You can certainly type the full import statement directly in JShell, like import java.time.duration, and then you can use the duration class.
Okay.
Or even more conveniently, you can use JShell's shortcuts again. If you type the name of the class you want to use, say duration, and then press Shift plus Tab, followed by the I key for import.
Right. JShell will show you a list of potential import options that match what you've typed. You can then select the correct one, in this case java.time. Duration in JShell will automatically add the import statement for you.
That makes exploring different parts of the Java standard library a lot less cumbersome.
Definitely.
You mentioned a help command in JShell. What kind of info can we find there, and how do we exit JShell when we're done?
The help command in JShell is a great resource. It gives you info about JShell's features and commands. You'll find details about things like navigating command history, editing input, using tab completion, declaring variables, and descriptions of other JShell-specific commands, which all start with A.
Right.
To exit JShell, you can just type exit and press enter. Or you can use the standard terminal shortcuts for ending a session, which are usually JShell plus D on Linux and Windows, or CMD plus D on Mac OS.
So JShell sounds like an incredibly useful tool, not just for beginners, but also for experienced developers who are prepping for technical interviews.
It's a quick and interactive way to reinforce your understanding of core Java concepts and to explore the language without the hassle of full program development.
Right. It really lowers the barrier to entry for experimentation and makes learning and reinforcing Java concepts more engaging and efficient.
All right, so let's recap. We've done a deep dive into some of the foundational concepts of Java, starting with the Hello World program and breaking down its structure, understanding keywords like public, static, and void.
Right.
We've seen how to compile and run Java code using the JDK, both from the command line and within an IDE.
Right.
We've talked about the importance of method calls on objects, understanding what instance methods are, how they operate on specific objects, and how they can either do things or give us back information.
Right.
And we've discovered JShell, this interactive tool for experimenting with Java code and quickly exploring its features.
And what's really key, especially when you're getting ready for senior level technical interviews, is recognizing that these seemingly basic building blocks, classes, methods, objects, packages, they're not just isolated concepts. They're the foundation of all larger, more complex Java systems. A deep understanding of these core ideas allows you to go beyond just answering syntax questions. You can talk about the underlying design philosophies of Java and how they contribute to creating software that's robust and maintainable. That's the kind of insight interviewers at a senior level are looking for.
So for our listeners out there, especially those gearing up for those senior level interviews, we highly recommend don't just try to memorize syntax, work through that hello world.
Yeah.
Example yourself. Get the JDK installed if you haven't already, and definitely spend some time playing around in JShell.
Right.
Getting hands-on with the language is the best way to truly grasp these fundamental concepts. And as you continue your preparation, here's a thought to ponder. Think about how these core principles of organization classes, packages, and the way we interact with objects through method calls, how these directly affect how you would design and build the larger, more intricate software systems that you'll be discussing, and maybe even architecting in your role as a senior software engineer.
What other concepts that might seem basic on the surface could actually have deeper implications and show a more profound understanding when viewed through the lens of your experience?
Right.
Often it's this deeper appreciation of the fundamentals that truly sets a senior engineer apart.
Absolutely. Food for thought as you embark on your journey to that senior role. Thanks for joining us.
It was my pleasure.